This is the 3D visualization with the ArcGIS API for JavaScript. We have Kristian and Johannes, and I'm Jeremy. And I didn't do anything for this slide, this presentation, so I'm going to go sit down here and watch. Turn it over to the experts.
All right. As Jeremy said, I'm Kristian Ekenes. I'm a product engineer on the JavaScript API, and I focus on the visualization APIs and what you can do in JavaScript within the browser. As you know, since last year, we've been able to work with 3D data with the API with the release of 4.0 and the current 4.3 release. And that is principally developed by our Zurich team, and Joe is here representing them. And so I'll be presenting most of these slides, but I'll do my best to make it conversational, and and Joe can comment on these slides as we get through it. So there's a lot of material to cover, and so we'll just dive right into it. The first thing to keep in mind is that when we talk about visualization or cartography, the principles in 3D are about the same as they are in 2D. They're not exactly equal. There's obviously major differences, but when it comes to the principles of making a good visualization, just keep in mind that a lot of what you might learn with 2D visualization still applies to 3D. And when it comes to our API, one of the aspects in which it is consistent or similar is the code. You'll notice that the coding pattern is very much the same, with very slight differences. And as I said, the cartographic principles and techniques are going to be similar. So we're going to break this up into three sections. And as part of this introduction, we're going to talk about what you can do right now in 3D with our API, and then we're going to spend the bulk of the time talking about how to do it, what does the code look like, what do the objects look like, and then we're going to close up with some considerations and pitfalls, what makes for potentially a really bad visualization versus a more visualization that makes more sense, that communicates a clear message. We're going to kind of pepper those pitfalls throughout the presentation as well, and so feel free to contribute to the conversation as well. Okay, so what can you do? So you'll see these categories as being as very familiar. We talk about visualizing location and types and numeric data in ArcGIS Online and the 2D APIs. Again, that's where it's similar with 3D. That doesn't change. What changes is the actual visualization itself, the look of it. So to start off, there's location. And that's when we talk about just visualizing location, we're just talking about a single symbol for all features in the layer. In the image off to the right, you see buildings in New York City. They're all, they contain mesh geometries, and they are visualized with the same color. We're not exposing any real data there other than that's what exists in that particular location. And similarly off to the left, it's, all the cities have the same symbol, all the highways have the same symbol. So there isn't really any data-driven visualization going on at all in this case. When we talk about types, that's where data starts to come into the picture. They're based off of unique values, usually text, but you can pretty much use anything, numbers as well, to visualize types. So we have off to the right, the usage type of the building, whether it's a commercial building, a residential building, or a mixed use of some kind. And then there's highway types or road types off to the left. Then we have numbers, and this is where we start to come up with more interesting visualizations. So this is driven by a numeric value. It can be a field, it could be a function that generates or that returns a number, and more recently arcade. We don't talk about arcade much in the context of 3D yet, but we will a lot more as we get deeper into this year. So keep an eye out for that. But in this presentation, we focus solely on field values. But just know that you do have those other expression options available to you as well. And there's a number of different visual variables, so to speak, that you can use to visualize that data. There's color, size, extrusion, that's unique to 3D, and opacity. Then you can combine any number of those to create, to show some kind of potential correlation. I don't want to say that that you can definitely say that the two variables are correlated when you're doing multivariate visualizations, but you can see potential patterns there. So you can combine color and opacity, size and color, or any other combination of those. There's really a lot of different combinations you can go with. You can go with more than two. I personally wouldn't recommend it because it tends to convolute the message and become difficult to read. Particularly with 3D, that is true. If you look at that image in the bottom right, that is, we're visualizing hurricane paths and the wind pressure as well as the magnitude of the hurricane. And it might make for a cool looking image, but what's really the most important is the message you're sending. So just keep that in mind when you're dealing with multivariate visualizations. This topic of hybrid thematic maps really falls under the same category, but what I mean by hybrid thematic maps is you're taking some real world aspect and trying to represent it as true to the real world as possible, and then adding some thematic aspect to it. So the examples here, you see the buildings off to the right are San Francisco. They have textures, so they look more realistic, and then you have color on top of them that visualizes the occupancy of those buildings. Something to be aware of with that, again, you gotta be really careful because the textures of the buildings mess with the colors that you're visualizing. And traditional cartography is, we take colors and size very literally and seriously. And so if you're trying to put a legend on that map, it doesn't really make sense to use that legend because those colors are getting distorted in your map. But then these other cases here tend to have less problems. So you have buildings, you have two variables there. Again, it's the building type with color, but we're extruding based on the real world height of the building. So the story there is it's just giving you a little bit of geographic context into what the landscape looks like. So the residential buildings in orange tend to be shorter, they're houses. And then, the hotels and condos along the beach are a little taller. So you just get a little more context when you do these hybrid examples. And again, it simplifies or removes the need for a legend. We're gonna kind of make this point a few times throughout is working with legends in 3D is really difficult, so be careful when you use them. And you may not even need them. I don't need to tell you that those, in the middle image, that those are trees. It can be pretty obvious, especially if you use a more realistic symbol, and we'll talk about that as well. This is definitely unique to 3D, is the concept of subsurface mapping. And this is particularly exciting in my opinion. You can take features that have negative Z values and render them underneath the ground in a local scene. When I say local, we project it flat. It's not on a curved surface, but we place those features where they exist in the real world. And you can do all sorts of things. You can do negative extrusions and basically apply the same principles of visualization under the earth as above the surface. Okay, so that's a brief overview of everything you can do. So how do you accomplish those visualizations? How can you create them? So to give you some context into how we construct this in code in 3D, it's nice to go back in 2D and see how it's done there, because again, these are very similar, but there's slight differences. The visualization is controlled by the renderer on the layer. When we talk about visualization in this session, we're mainly talking about a feature layer or a scene layer. So it's the renderer that controls that. And then you have 2D symbols and then visual variables. How many of you are familiar with visual variables with our API, by the way? Just by show of hands, so I can have some context and know what I should. Okay, so not very many. So we're going to talk more about visual variables later on, and we can play to that as well. So the difference with 3D and 2D is that each symbol type in 3D is composed of one or more symbol layers. And if you're familiar with working in ArcGIS Pro or ArcMap, and you create, say, a custom symbol, or you want to modify an existing symbol, there's this concept of adding a layer on top of the symbol, or you can stack different symbol layers. This is very much the same, and it's the symbol layers that really control what the 3D visualization is, and that'll make sense later on in this presentation. Whereas in 2D, it's just the symbol. We don't expose symbol layers in 2D. But you'll also notice that our examples only show one symbol layer. And Joe, can you comment on that? I believe it's a spec issue at this point, right? Why we?
Exactly, yeah, it's kind of a tough one. I mean, we added so we created a new model for 3D symbology, like spec-wise and API-wise, and we want it to be future-proof, and we want to be going into the direction of having multi-layered symbols like Pro already does. So that's why we introduced it from the get-go, so that we wouldn't have to break in the future. Right now, you can already use them. It'll just put multiple things at that place, essentially, but we kind of lack the capabilities to make this a really useful feature, but that's something we're working on right now. So I hope that by the end of the year I have a better answer to that.
Yeah. All right, so let's talk about symbols. So if you're familiar with 2D visualization, these symbols will look familiar to you. There's the simple marker symbol and simple line symbol, simple fill symbol. All those are supported in 3D with the exception of picture fill symbol. However, we don't recommend that you use them because we have these other 3D symbol types that Joe was just talking about. They're designed specifically for 3D scenes. So these are the symbol types. When we talk about 2D symbols, you can kind of mix and match which 2D symbols go with geometry, particular geometry. For example, you can render polygons with a fill symbol or a picture fill symbol, but you can also render a polygon with an icon in 2D. That's not the case in 3D when it comes to the actual symbol object itself. You can accomplish the same visualizations on the symbol layer level, and I'll show those examples in the following slides. But just know that when we talk about the symbol classes, you see them listed there below: point symbol 3D, line symbol 3D, polygon symbol 3D, mesh symbol 3D. Those are named intentionally because it makes it easier for you to know, okay, I have line data, I know that I need to use a line symbol 3D. I can't use any of the other objects out there. So just keep that in mind. That's for consistency. But then we talk about 3D symbol layers, and we group them into two different groups. There's flat symbol layers and volumetric symbol layers. When we talk about flat symbol layers, if you look at those images off to the left, they're essentially 2D symbols, right? If you see fills or icons or lines like that, you can, they're 2D symbols, but in the API we call them 3D symbols because they fall under the same classes as point symbol 3D, and we describe them as flat. And then there's the volumetric symbols. This is the traditional idea of a 3D symbol where it occupies 3D space. And these highlight some of the differences between the two. Flat symbol layers occupy screen space, and therefore when you are defining sizes with flat symbol layers, they're using screen units, so pixels or points. Whereas with the volumetric symbol layers, we're talking about symbols that occupy space in the virtual world. And this is where it gets a little weird with 3D. It's not totally weird, it's just different, I think, initially. It's where you can create thematic visualizations, such as that extrusion of polygons off to the right. Those sizes are expressed in meters, and so that's kind of an odd thing to wrap your head around at first. But the reasoning behind that, there's a definite design reason for that. Do you want to comment on that, Joe, on the screen space versus the virtual space for these?
Yeah, so I mean, one of the reasons why we don't call them, well, there's multiple reasons we don't call them 2D, or we don't want to call them 2D symbol layers. First of all, you use them in the scene view, you don't use them in the map view. But also, they have a lot of 3D component to it. For example, the polygon may have z values, or the line is maybe simpler, it may have z values, so it's maybe a spiral in space. Obviously that's not a 2D kind of construct, but when you visualize that spiral, you have two options, the flat, the volumetric one. The flat is like if you, let's say you printed the path of that 3D spiral out on paper, and then you take a pen and you follow it. That's what you get with a line symbol layer 3D, which would be the flat representation of it. So it's kind of like, it's kind of a mix between the two. Whereas if it's a volumetric one, you think like, okay, now I'm creating like a cardboard tube around that thing, and then I'm making a picture of it, and that's my visualization of it. So that's kind of the difference.
Yeah, and because it occupies space in the virtual world, the other thing to keep in mind, particularly with point data, is that we don't have a single property for size. You can have, there's 3 axes, height, width, and depth. So if you think of a, like what do you call it, an ellipsoid, where you can have like a football type shape, like one dimension has a certain length, but then different dimensions have different sizes. So you can define that all in code. So again, this slide just reinforces the concept that you have these symbol layers within the 3D symbol. The 3D symbol itself doesn't do a whole lot. It's just a container. So most of the properties you define will be on the symbol layer level. And then of course there's visual variables, which we'll get into in a bit. But first let's go through each symbol type and the different options you have available to you. The point symbol 3D is, like Joe said, you'll notice that each of these symbol types have 2 sides of the coin. So there's like a flat symbol layer and then an object or a volumetric symbol layer. In this case, it's icon symbol 3D layer and an object symbol 3D layer. And the main difference here is that icons are expressed in points or pixels, and then the object is in meters, so width, height, depth, and meters. So what does the code look like when you create one of these symbols? So notice the point symbol 3D object. It's the only property we set on that is the symbol layers property, and that is true of all these symbols. So we're going to declare a new icon symbol 3D layer and set the size. By default we use points, so that's 12 point size, and then there's other properties. The color property is inside the material object, and then there's an outline, which is obviously the outline. You can set a color and a width or a size on that. And then there's the resource, and there's several different options with the resource. We have several primitives available to you within the API, and I'll show you a slide for that. And that is true of both object and icon symbol layers. So in this case, notice the sizes there. Again, that looks a little strange at first if you're used to 2D symbols to have, because when I first look at this, I think, oh wow, 70,000 pixels, that's a pretty big icon. That doesn't make any sense. But again, it's 70,000 meters, and it sounds like a lot, but if you're on a global scale like that, that's the type of visualization you'll get with those numbers. And again, the resources are going to be different. They're, in this case, a cone. And so these are the different resources you have available to you for object symbol 3D layers. These are just simple shapes or 3D shapes that you can use right out of the box. But Joe, would you like to explain these other resources that are new to the API as of this latest release?
Sure, yeah. So apart from the primitives, there is actually already the option to have your own 3D model. So if you could potentially model your own, I don't know, chair and then use that one. But we realized that this is not an option that's available to many of you. So what we did is create a library of many different objects that you might want to use in your maps, and we will keep extending that library actually. That's what we call the web styles. So yeah, it contains assets for like street, like payphones, light posts, park benches, and then vehicles and vegetation like trees. And maybe you could briefly, did you have the guide page open?
I don't have it open, but I can show it. First I could show this too. This is an app that shows a thematic visualization of population in Switzerland. And here we're just showing off the different primitives you can use. So cones tend to work really well, I think, in these types of scenarios where you're showing a total count. But cylinders also work nicely. Cubes, you know, it just kind of depends on what type of visualization you're looking for. You got tetrahedron and others, so you have those available to you.
Just one quick hint: if you're using a ton of them and it's slow and you're using cylinders, you might give it a try with cubes because it's easier to render for the computer.
So if you go into the documentation for the JavaScript API, we have a working with the API section. And then if we go down here, you'll see a visualizing points with 3D symbols page. And this talks about the workflow of bringing in these web styles. And that is with the web style symbol class. We're not going to get into the mechanics of that, but just know that it's actually pretty simple to use. We have them all listed out here, all the names. So if you see these really detailed symbols and the one that you like, maybe this ambulance, you can just click on it and copy and paste this code into your app and you get that ambulance symbolizing your features. So it's really a handy page. I encourage you to check it out and to play around with it and get used to using it. And again, that's the structure of what the web style symbol looks like. It's essentially, you got different groups, that's the style name, so it might be a street group or transportation, and then you have the name of the symbol itself. And those are the pages that I just showed off. And those are the primitives for the icons, nothing super new there. But when we're talking about point symbols, keep in mind that there's different looks you can get even with the same symbol layer. So there's a concept of draped versus billboarded icons. So just to give you a feel for how they both behave. In this app, I've got the same data. This is earthquakes, and the size renders the magnitude of the earthquake. And when they're billboarded like that, notice that the symbol it's always facing you, kind of like no matter which way you rotate or tilt, it's always occupying the screen space that way. And then if they're draped, they're just simply draped on the surface like that. Joe, do you want to talk about those differences? Like the one on the right is an image, correct? Whereas the one on the left is their graphics? Or?
Yeah, I mean, you could say so. It's what we do essentially is like we can either render that icon on the screen as you would in 2D or like in a canvas, or we can first render it into a texture and then drape that texture over terrain. So first one is the left hand side, the second one is the right hand side. And I guess it depends it depends on what you want to visualize. If it's kind of a point of interest push pin kind of thing where you just want to draw the attention to a certain location in the map, the billboards are great because they're always visible the same way, right? They're always facing the user and making that message. So you can see that here. On the other hand, if you want to visualize some certain quantity or so, and if you want to be able to also compare the sizes of different circles, or maybe they represent a certain radius, then you want to drape them and put them in the map because as you can, like, if you tilt those dense billboard markers, they start overlapping in each other as you sort of you destroy or you put the horizontal dimension into a single line, and then all of a sudden they're all in a single line. You don't really see the relations between them anymore. That's actually also the case with the draped ones. You're right, but yeah.
Yeah, it all kind of depends on what you want to do and what type of visualization you're trying to accomplish. So again, the point of interest sample, I think it's quite clear that billboarding is the way to go. Whereas, if you drape them, like in this example up to the right, you don't see any points of interest when you're at a certain tilt with varying elevation like that. But this line symbol though is draped, and it makes sense to drape this one because it just creates that effect of a trail on the surface of the mountain.
There's a technical reason there actually. You can put Z values onto the lines, but it's a hard problem in 3D to make a line that exactly follows the terrain, especially because the terrain system that we use uses different levels of detail. You can see that when you zoom in, it loads in further detail, and the surface actually changes shape. So in order to pull this off nicely without draping, we would have to change the shape of the line all the time. That would be very expensive. So the easiest way to get lines or polygons that adhere exactly to the terrain is to just drape them, because then that comes for free.
All right. So moving on. So line symbols, again, pretty straightforward. It's only for polylines. You have the flat version, which is a line symbol 3D layer, and then you have the volumetric version, which is the path symbol 3D layer. And so when you're doing something like a flight path, like either of them I think look okay. You can use the billboarded line symbol or that tube-like path symbol. And these are pretty easy to construct. They're not as complicated, you might say, as the point symbol 3D resources or symbol layers, because you don't have those different shapes. It's either a path or a line, and the main thing to keep in mind is, again, the size. The size of that diameter on those tubes is 5,000 meters or 5 kilometers, and then you define the line symbol 3D in pixels or points. And then polygon symbol 3D. You can actually do a lot more with this, but these are the two main ones. You have the fill symbol 3D layer, which has no size. So all you have to define really is the color and the material property, and then the outline. Whereas the extrude symbol 3D layer, this code snippet isn't very good, I'm sorry, I should have changed it. But you can create, it has a size property within the extrude symbol 3D layer, and that will drive the size in meters as well. Or the height. That one, you don't expand that out in the other sides as well, it's just a height that you drive.
I guess the thing here is that you hardly ever want to do an extrusion with a fixed height. Like in almost all cases, you will want to attach the extrusion height to some data. Like for example, it's the height of buildings, or in this case, it's some kind of numeric values. And that's what we're going to talk about in the context of visual variables. So you'll almost always want to use visual variables with an extrude symbol.
Correct. So maybe it's not such a bad code snippet. But so you can actually also use these other ones we talked about for the polygon symbol 3D. I wouldn't recommend the line symbol 3D layer because you already have the outline property in the fill symbol 3D layer. So that one is kind of obsolete in this use.
Yeah, it's legacy actually.
But you can also do that other use case I talked about at the beginning, where you can use icons or even those objects to symbolize polygons. So in both of these cases, we're rendering polygon data with point symbol layers. And then there's only one symbol layer available for the mesh symbol 3D, and that's the same one as you can use in the polygon. That's the fill symbol 3D layer. You don't define size there because that's inherent in the geometry type. You just define color. Okay, so now that we have the structure of the symbol down, hopefully you've gotten used to how those all look. Let's talk about the renderers. You'll notice that the renderers are all the same as in 2D. If you're familiar with 2D visualization, the properties are not any different. It's when you get the 3D visualization, that's all driven from the symbol layer, as we talked about before. So this is what all of these components look like in context. You have, in this case, I want to just visualize location. So I'm looking at the cities layer at this point. So it's the points, the orange points. I'm setting a single symbol on the renderer, and it's a point symbol 3D with a point symbol 3D layer or symbol layer. And I'm setting a fixed size and color and outline. Again, nothing special. It's not data driven. It's just showing location. This is the combining of, maybe it's a data-driven value with value from the real world. So you can get a particular effect. So if you see those side-by-sides, that's what the 2D map would look like if you're rendering this data in 2D. If you're just showing building type here. But in 3D, you can, because of tilting with the camera, you can bring some more context into it. So this is just meant to show you how the visualizations can look different. Either one I think looks good. They communicate the same message, it's just you gain that additional context with 3D. And so this is what it looks like. As Joe said, in the polygon symbol 3D, if you're using an extrude symbol 3D layer, you're not typically going to use a size. You just set the color or just take the default. And then when you plug those in, you can plug it into unique value renderer. In this case, we set a default symbol and label, so that's any of the features that don't match the values set in the unique value info array will fall under that category. Notice the field property, so that field name, which is not very descriptive, you can't really tell that that is talking about building type, but it is. That is what is driving the visualization. So when the value is residential, we're going to assign this res sim object to it to symbolize it, and similar with the condo, we set the different colors. And then this is where the visual variables creep in. Notice that we just pass in a simple object to the visual variables array, set it to size, and we set the field, okay, elevation in this case is kind of confusing, but for this data it means the height of the building. And then all you have to do is set the value unit property, and that's basically indicates I want to map 1-to-1 in feet what the value is of that field. So if it's 90 feet, I'm going to render it in 90 feet in the view. So it's really quite simple to do that in visual variables. You also have a ClassBreaksRenderer available to you in 3D. When we talk about ClassBreaksRenderer on the web, it's you can use it if you want to. It's certainly, sorry, that makes more sense if I put those other snippets off to the left. This is a render that I think makes more sense when you're making a paper map, maybe in 2D, because you can clearly map a legend, and when you look at a feature, you can know which category that feature falls into. But you do have it available to you. You can certainly use it. I'm not saying don't use it. There's certainly use cases for it. It's now with visual variables, though, you can make, in my opinion, more interesting visualizations with continuous color or continuous size or opacity. And so just this is just to show you the difference between this and the unique value renderer. Instead of unique value infos, you have class breaks. So you have min and max values, and if the data of the feature falls within one of those breaks, you're going to assign a specific symbol. And so that symbol is going to have a specific color. If you're using extrusions, it's going to have a specific size. I think that's the one case where you might set a size on the extrusion is if you're using class breaks. But again, I would prefer visual variables myself. And then, yeah, so that's what that looks like. So visual variables. This is, as you've already seen, it's a property of the renderer, and it's principally for, or it's exclusively for numeric, data-driven, continuous visualizations. And so there's a bunch of examples there. You can do color, you can do icon size, extrusion, you can do a combination of the two of them. You can, when you're doing extrusion, as in like that example in the top middle there with the brown extrusions, that's actually mapping the same variable with color and size. We've noticed that as we've experimented with these visualizations, it's actually really nice to do that, to combine the same, to visualize the same variable with color and size. That's not, in traditional cartography, I think that's generally frowned upon, but in 3D, it tends to communicate the message more clearly in many cases, if not most of them. And then, but then if you look at the icons off to the right, it's using two different variables. So what are the different visual variables you have available to you? First, you have color, and that's what the structure of the object looks like. You just set a field. I recommend normalization field for color because that tends to communicate the message more clearly, and you're not deceiving people as much when you normalize your data. And then you set stops. So on the lower end, you can bound it and say, okay, I want to make a pale color if the percentage of the population in poverty is less than 10%. If it's above 30, we're going to make it a deep purple color. And for all those values in between those two, we're just going to just map them linearly. And you can set any number of stops. If you don't want to do a linear visualization, you can set various stops along those values to create a custom one, but linear tends to work out pretty well. So this is one thing to keep in mind with color, is that in 3D, you have to have shade to create a 3D effect. And so color can't be taken too seriously, especially when you're dealing with a legend. So if you have a legend, you can't just look at the color of the 3D object and say, oh, this doesn't exactly match, it must be somewhere else. That's not necessarily the case. So that's why legends, in my opinion, don't work super well with thematic visualizations in 3D. Because these are the same features, and you can clearly tell that they have a different color depending on the angle you're looking at. Do you want to comment on that, Joe, and you know, kind of a little bit on the history of that and where we're going?
Sure. Yeah. I mean, again, as Kristian already said, shading in 3D is a necessity to make you actually perceive the 3D shape of things. At least in this case, where it's unicolored, like just yellow and brown blobs. So we cannot have use just one color and color the entire thing in that color. You would not see the shape anymore. So we use this, what we call lighting in 3D. It's kind of like virtual lighting. And so everything that Kristian has said, and I guess an additional takeaway message from that is you cannot rely on brightness to convey the magnitude, or convey like numbers. You have to set up your color ramp so that they show difference in hue, so that regardless of the brightness, you can still perceive what color is it and still perceive the difference. Are actually working on, so right now these differences are pretty strong in the scene viewer. We're working on a new lighting model that will be less realistic. So right now, I don't know if you've experimented with it, you can set the time of the day, and then you will have the sunlight coming from the right direction and everything. So that's nice for certain applications, but for pure thematic mapping, that's unnecessary and actually harmful. So we're working on having a more nicely even lit scene or view for these kinds of visualization.
And really those lighting settings are just trying to get us to mimic the real world as closely as possible to reality. So, I mean, if I look at this pulpit here, let's call it a pulpit, right? Or whatever that brown thing is. It's all the same color, but I see different shades of it, and it has that 3D effect, and that's really what's going on here. So you can also, again, use the flat part of visual variables. And notice that, I guess I didn't show visual variables for size there. The object looks exactly the same. We don't indicate extrusion or flat or anything in the visual variable. Remember, that's all on the symbol layer. So if I have an extrude symbol 3D layer, that's going to extrude those polygons. If I have an icon symbol 3D layer like I do here, it's going to make those icons. But note that the size is in pixels. And if I want to do, say, extrusion, I need to set that in meters. Otherwise, you're going to be like looking at it, where's my data, when it's really, really, really tiny, because you're trying to set pixels on it. And so it's really up to you. I mean, we provide both these options, you know, when it comes to size visual variables. It's up to you which way you want to go, whether it's extrusions or icons. I think extrusions, that's kind of more of the attractive way to go with 3D, and it communicates the message pretty well. In this case, I'm not symbolizing the same variable with height and color. I'm doing the normalized percentage of the population in poverty with color, but then the total count of those in poverty with size. So you kind of get a better picture of where more of those people exist versus where a higher proportion of them live.
And you can see us struggling with the legend down there for the size. Like the question is, how do you make a legend for the size of a 3D object? As you zoom in and out, that object will grow larger and smaller, and like it'll grow gigantic. We cannot make a legend that now tells you, okay, like it means that much. So we revert to just kind of like a hint of what it means in this case.
So yeah, again, like this legend, you can't take that literally, you know, and even, you know, you look at the perspective here, this is another one of those caveats. You know, those features in the back of that front feature might be taller. In fact, they are if we tilt it this way. We know they're taller in southern Florida, but this one appears taller because of the location of the camera and the perspective with the tilt. And that's because, again, we're visualizing, we're mimicking the real world there. And I think that's something that's really intuitive for all of us. We know that sizes, similarly sized features, are going to look different. You know, if I have both my hands, this hand looks taller than this one. Even because it's closer to me. That seems to be pretty intuitive for the most part. So just don't take the legend too seriously if you're going to end up using it. So then, there's this real world unit case. You already saw that with the building height, but this is a case where you can set multiple visual variables to create an image of the real world. In this case, this is dealing only with the tree trunk. So I'm setting the height with the height field on the height axis of the object symbol 3D layer. And I'm setting the value unit to feet because that's how it was measured, but the trunk width was actually, or the diameter was actually measured in inches. So notice that I set the value unit to inches. So you don't have to do those conversions from meters to whatever other unit. That makes it more complicated. So it's really handy to just put that unit into the value unit property and it takes care of it for you when you're mapping the real world sizes. And then there's opacity. This is no different than 2D. You can drive the opacity based on a field value and set the stops like you would color. However, keep in mind that opacity right now is difficult to work with in the browser. The features, we're looking at the same data here on the right, where it's dense, and if you're looking at it from different views, you can see through it on one side, but on the other side, you can't see the features from behind. So opacity tends to look better when you're dealing with features that are not quite as dense. When they're more spread out, you can get away with using opacity more. Again, do you want to comment on this?
Yeah, I mean, the reason for this picture on the right side, that it looks so different from two sides, is really rooted in the fact that it's really hard to get transparency rendered right in 3D computer graphics. Like everybody, like games, everybody struggles with that problem. It's just hard to get it done right efficiently, and so we're no better. We're pretty bad at it. We have all of these artifacts. We have some ideas of how to improve that as well in the future. Hope we get to it soon. But even then, notice that, like, if you look at the top picture, as soon as you have multiple surfaces layered behind each other and they're all semi-transparent, you start, like, you cannot really perceive what's going on anymore because there's so many things moving and they're all kind of fudged together. So I think even if we had perfect transparency rendering, that point holds that if you have dense things, like many layers of transparency behind each other, you cannot really make sense of the picture anymore.
And then finally there's rotation, the rotation visual variable. We do support rotation, but note that we don't, it's only in certain cases. So when it comes to icons, we don't support it. Whereas in 2D, you can, like in the image off to the right, you can render rotation quite easily. But when you have a tilted view of the world, rotation is harder to visualize. Like, for example, when I have that icon in the middle, depending on how I tilt, I don't know exactly where that's pointing. Is it pointing up? Like, is it pointing to the sky, or is it pointing north or south? Like, I don't know, I can't tell. So that's something we're still trying to figure out. However, we can symbolize rotation in object symbol 3D layers because it's they just have that 3D aspect to them. So here, there's actually two layers that are being visualized with rotation. There's the cars on the street. Notice that they are positioned going the correct direction. They're different symbols, but they by default would point the same direction. But because of rotation, we can have them look like they're going in the right direction on the road. And then there's the park benches. Notice those off to the left on that circle. They're all facing inward, and they have a field indicating which way that park bench faces.
So these are all point data sets that are visualized with the web styles. This is not a multi-patch kind of thing. That's why. So it's originally just points, and then we use the web styles, the park bench. It's actually a nice example for what you can do with the web styles, and then there's the rotation aspect to it.
You want to talk about the more advanced cases for those here who might
Yeah, sure. So yeah, I mean. Like I said in the plenary, there's so many different things you may want to visualize in 3D, and I actually know that people want to do it, and there's so many good use cases for it. We cannot possibly, or at least not quickly, cover all of these use cases, and it's not possible to cover them in a generic way. So if you really do have a specific visualization need, there's a way to do it. You can use kind of our engine for everything that or the JavaScript API for everything that you've just seen that it can do, and also for the terrain and everything, and then render your own visualization on top of it directly in WebGL. So then you can do whatever you want. You can have something animated, you can have something glow, or things like that. But this is hard to do. This means you have to be the game developer that actually writes the GPU code that renders that on screen. So, it may be prohibitive for smaller projects, but like if you really have the specific thing in mind, maybe you can find somebody who can actually implement that for you.
So that was an app that one of our developers, Jesse, created, where he's creating a realistic visualization of the water, where you can even set the wave height and the velocity of the water, which is pretty cool. But again, a lot of work, it's experimental. That API will change as the technology changes, so just keep that in mind. 3D smart mapping, this is pretty new. This is new as of this year or the end of last year. And so the concept of smart mapping is that you don't need to guess the good default values. You can have them generated for you based on statistics. And it's all about, trying to get a good default. You certainly don't have to use what is returned from the smart mapping APIs, but it's a place to start, and it's also a great way to explore your data if you're unfamiliar with it. This has been really popular in ArcGIS Online with 2D, and we're excited to release it in 3D. We do have limitations. Right now it's limited to only point data. So if you've gone into the scene viewer and played with smart mapping, you'll have noticed that you can't just bring in your polygon layer and play with it, or your line layer. It has to be point data. So we actually have a sample in the SDK that, in the documentation that shows smart mapping. I've just taken that same exact sample here and attached a data set for world population to a slider. And so you can see how well it performs even with a lot of points here. This is a feature layer, or I believe it's a feature layer. Could be a scene layer.
Yeah, could be. I don't know.
Yeah, we support both layer types, but it's pretty cool. It's a good tool for again exploring your data. Again, we have a separate. Jeremy and I will be talking about when to use smart mapping in custom maps tomorrow. So if you're interested in smart mapping, we'll cover a specific use case there. We're not going to get into the internals of it here, but if you're interested, please attend that session. It will be good. And so this API will continue to improve throughout the year. We're going to add support for more types, more geometry types, as well as generating unique values and things of that nature. And this is also a new feature. Do you want to talk about the point cloud layers, Joe?
Yeah, sure. So yeah, point cloud layers it's a different data types, but actually we use very similar ways to visualize it. Instead of using symbols, or let me put it like this: you cannot assign a symbol in a point cloud layer. It'll always render as a circular disk essentially. But what you can do is you can use different renderers to visualize numerical values. So there's first of all, there's the RGB renderer, which is a special case in point clouds, that point cloud datasets often or sometimes come with RGB, like with actual color values at that location, and that's what the RGB renderer is for. And then there's a stretch renderer, which it's kind of like what you would use visual variables for, a color visual variable for with the feature layer renders. You do it with a stretch renderer in point clouds. You can assign a color ramp by height or by another attribute. And then there's unique value render, exactly the same concept as with the unique value renderer you've already seen, and the same with ClassBreaksRenderer. So the only thing is with these renderers, you can only ever assign the color to the symbol, not anything else.
So we've already gone over considerations and pitfalls that you may fall into. Just to kind of summarize or to close up, you can add any number of visual variables to your renderer, but that doesn't mean it's a good idea. I've tried it, and it's made for some really terrible visualizations. Some of them look really cool, but I mean, if I show it to someone, they have no idea what's going on. I don't even either, actually. So just keep that in mind. Keep it as, you can make complex visualizations, but keep the message in mind in the audience. You know, how are they going to understand it? Does the legend make sense? You know, those types of things. And be aware of scale. Okay, we're talking about, with object symbols, real world units. If you are rendering, whether it's points of interest with object symbols or park benches or anything, even if it's thematic data, when you zoom out from a certain scale, that we don't change the size of those symbols based on the scale like we do in 2D. It just doesn't really make sense when we're using the real world units. So think about what you do when you change scale. Are you going to flip the render over to show icons, which do scale out when you, they stay the same size as you zoom out. So be aware of that. Generalize your data when you need to. You don't need to put zillions of points all in the same, in a very densely congested area. You can generalize, maybe use polygons. Also, the scene layer versus the feature layer. The scene layer generally, do you want to talk about that, Joe? You'd actually know more about that, I believe, than I do, but like the differences in performance between the scene layer and the feature layer in 3D?
So, I mean, the scene layers, we introduced them specifically to 3D as a means to very efficiently be able to display a lot of data, like millions of points, millions of buildings. And so you can use both. We have a limit. Actually, in the API, the limit is the same for 2D and 3D. But you'll notice that if you put more than a few thousand features with complex polygons, maybe even more than 1,000 already, then it'll get slow. It'll take a long time to load, and that's where the scene layer comes in. In the scene layer, we have the chance to only load certain part of the data that is currently needed for your current view. That also means that when you move somewhere else, we'll load a different part of the data. It's kind of similar like on demand in 2D, except the feature layer didn't really allow us to do that kind of experience that we wanted with on demand in 3D. So that's what we created the scene layer for. So whenever, like if it's a small data set, it's totally up to you to use a scene layer or a feature layer. But if it's pushing thousands of features, then you should definitely use a scene layer when you can.
All right, so just wanted to point out some helpful resources. I blogged about this subject over a year ago, I believe. In that middle section, there's a series of blog posts talking about these symbols. There's different apps you can take a look at, code snippets. We also just released a symbol playground at 4.3. I'll go ahead and show it to you. Just because it makes I think the development experience a little easier for you. So if you go to the sample code in our SDK, and then just search for playground, and you'll see it here. Let's go ahead and view it live. Mohan on our team developed this, and again, you can select any symbol type. So we do provide the 2D symbols, but again, I think it makes more sense to choose a 3D symbol, or a 3D symbol type for the scene. So you could choose realistic street, and then maybe a dumpster, and you can see what the web style looks like. There it is. It's small, but you can zoom into it. There it is. So with any other symbol type, so let's go ahead and go back. So maybe the point symbol 3D, you can then select your symbol layers here and add the properties and to see what it looks like. Design your symbol, and then copy your code here, and then paste it into your app, and it will work. So that's the symbol playground. And I encourage you to look at that. We also have a Get Started with Visualization page. Encourage you to read that, provide feedback if there's something that doesn't make sense. We want to make this as easy as possible for you. And really, as you've noticed, that this is really, in my opinion, a world-class API. You don't have to know WebGL to create really complex visualizations. It's just simple code, setting properties, working with visual variables, and you can create some pretty cool visualizations with our API. I encourage you to take our survey. Let us know how we did, if the content was relevant, how we are as presenters. We take the feedback seriously. We want to go ahead and open up for questions for the last 5 to 10 minutes or so and see if you guys have any questions. Yeah.
You were talking about the need to switch symbology types as you change scale, and you don't want to use something that's in real world units, as you say, as you zoom out. I know it's possible to do a watch at the zoom level and swap out renderers, but right now there's no way in the API to do that easily. You end up coding something, whereas in 2D it's very easy to set different renderers that are scale dependent. Is there any plan to do something like that for 3D?
Yeah, Jeremy, do you want to comment on the scale dependent renderer? Are we going to bring that into what? Yes.
So I mean, what you can already do actually, there's min scale and max scale on the layers. So you can add the same layer twice and assign 2 different renders on it. And yeah, and also I guess it's.
It shouldn't show up in the legend twice because the legend will take the scale visibility into account.
Actually, the problem is in 3D. Scale in 3D is a sore topic.
Oh, right. Yeah.
and the way it's currently implemented in the APIs that we will use different scales for different features on screen when you're in a tilted view. So this means that you won't get what you can't do right now is get only a visualization of one kind or only the visualization of the other kind. It'll be a mix, and that will also actually make it appear twice in the legend, I guess. So.
Yeah, you have to think differently in 3D in terms of scale because of what Joe just said. So.
I understood, but I also have to listen to that else.
One thing to consider is that so let's say you have these real world sized objects, and as you zoom out they will become very small and just vanish. So what you can do is you can just add an additional layer with icons and then only show them at a certain after a certain scale. So then it means that as the things become small and you can hardly see it anymore, an icon will pop up. You don't even need to actually make the other ones go away, the real world objects. They will also just be overlapped by the icons in the end.
Is there a terrain elevation sample on the playground?
There's not in the playground, but there's absolutely samples in the SDK. If you go to sample code, there is. I'm not sure what's there, but I'm sure there's at least one.
Yeah, we have several elevation samples. We have talking about query elevation, I believe. So this one toggles different elevation layers. We have the default world elevation layer that we provide in the API, and then you can toggle it with a custom layer that you create. But these samples do most of the 3D samples do use the world elevation. So. For example, the scene layer, like the realistic buildings, we do use elevation here because they have a specific position, and if we don't use elevation, it appears as if they're floating above the surface. So you can take a look at these samples and see where that elevation is plugged in, and you can play around, take it away, and see what it looks like. But yep. Any other questions?
All right, thanks everyone.